Today's agenda is, obviously go through HashiCorp Vault, so engineering training. We're going to dive into both a technical perspective and around use cases, why Vault is important, for customers. We're going to talk about, how does Vault, protect data, walk through the key components within Vault, talk about high availability, disaster recovery within Vault, discuss some of the enterprise features. So a lot of the stuff above, I'm going to focus on open source, and then we'll touch on the enterprise features. And then there will be a new update in regards to licensing that I just had a discussion with HashiCorp on Friday, I believe. I am not sure when those are going to be applicable yet, so those are still to be determined. HashiCorp's actually in their SKO this week. So let's kind of get started here. So when we talk about, passwords as a whole, right? So we talk about, we want to talk about the problem, right? So what is the current state, of passwords, right, in the enterprise? So, everyone's like, where are our passwords at, right? So you may have, this guy using 1Password, this guy using LastPass, right? A locked Excel sheet. I may have it on a Post-it note, right? Obviously, some of those are secure, some of those are encrypted, but the problem is, sharing within the enterprise, if the guy on the left there is gone, right, then we don't have access to his passwords any longer. So I know as a system admin back in the day, that's how we ran, right? Everyone had their own local password vault, and that's how we stored passwords, and a lot of times, they were not synced, so we didn't have the same stuff across the board there. Again, as I mentioned, because they are not shared, sometimes we run into a problem like this. So, production SQL is down. Who knows the password for the service account, right? Jim set it up. Ask him. Jim's on vacation this week, right? So we may have problems with the fact that, again, they're not shared across the business, and it could cause problems, within our production environments. Could stall projects, et cetera, waiting for folks to, come back, whether they're on vacation. Then you get this guy, right? Set it up. Your service account will always work because the password never expires, right? So then we also have passwords that, are long-lived. So they're set up as service accounts. Password never expires, and they may, live for years, right, with the same exact password. So that also poses a problem. So again, you got to think about when was the last time passwords were actually rotated, right? So it could be, days, months, years, never. I mean, I know, again, as an admin in the past, we had service accounts that probably been around forever with the same exact password, right? And that's not good from a security perspective. And then what happens when you get this? So, what happens when a guy, somebody walks out or gets let go or, decides to take another job or something like that? You have a lot of tribal knowledge that folks have when they leave, and, you may have passwords and stuff like that walks out the door, and now you have a former employee who knows all the critical passwords for your systems as well. So how do you make sure that when somebody walks out, you can revoke all those secrets, easily issue new secrets, and, your systems are secure again? So that's from a password perspective. So let's look at, current status from just an infrastructure point as a whole. So obviously not everyone, but the majority of folks, especially that we're working with, are moving to, some type of public cloud, AWS, Azure, GCP, et cetera. So what that causes is usually a refactor of the applications, introduction of new tools, et cetera. So while, the current status or current plan may look something like this, nice and clean, right? We've got our options to retire, convert, refactor, reshift, right size, all that kind of stuff. A lot of times this is what it actually looks like, right? And so when we start using a lot of these tools across the board for public cloud, we've got SaaS, we've got, on-premises, we're trying to automate all those pieces as well. And we start automating a lot of those, we're introducing, things like Jenkins, things like, other pipeline tools, VRA, VRO, automation orchestration tools. Each one of those generally has their own passwords, right? So now not only are we, have a problem with sharing passwords, but we're moving to services that are creating more passwords, more requirements to authenticate across the board, right? So the question is, how do you manage the secrets across all these platforms when now you're expanding or migrating to cloud, and you also have all your on-prem stuff, right? So obviously, today the focus is Vault. So this is what we're going to kind of go through today. So Vault, this is kind of the HashiCorp definition here. So It secures, stores, and tightly controls access to tokens, passwords, certificates, API keys, and any other secrets in modern computing, right? So the underlying piece of Vault is a KV store, so key value store. So when it says tokens, passwords, certificates, it really means anything you can store in text, you can put in there and protect, right? So when you look at the features of Vault itself, the capabilities and features that you want to look for, what customers are looking for to solve, right? So Vault stores long-lived secrets. So as I mentioned before, sometimes you create those service accounts, et cetera, that have passwords that live forever, right? They could live days, months, years, whatever. So you can store those in a secure, encrypted, database, if you will, and be able to access those, across the team now, so you don't have those individual password vaults. So with Vault, you can dynamically generate new secrets. So rather than store those long-lived secrets or use those long-lived secrets for your applications, we can dynamically generate new secrets on the fly. So my example before was Jenkins. So Jenkins may have, a lot of folks will create a long-lived account, say in AWS or Azure, for example, to give Jenkins the ability to go out and deploy and provision resources for you. The problem is that Jenkins more than likely only needs that access for 5 minutes, 10 minutes, however long that job is running for. But the problem is when you create that username and password, or say in AWS the access key and secret key to give it programmatic access, once the Jenkins job is done, right, that account still lives on. It's not destroyed, it's not whatever. So that same account persists regardless of if Jenkins actually needs those credentials or not. So what we can actually do is use Vault, integrate that into our Jenkins pipeline, and we can say, before Jenkins goes out and deploys, resources in AWS or Azure or wherever else on-prem, we can say, hey, go get me, credentials to go be able to do this. So Vault can go out, dynamically create an AWS user with an access key and a secret key. It can pass that to Jenkins. Jenkins can go out and do the thing it needs to do. Then after it's done, we can actually revoke that access so that account no longer lives beyond the requirements of what we're using that account for. So we can do that a lot of different backends, so AWS, Azure, GCP. We'll talk about that as well. So manage leases on secrets, important too. So as I mentioned, we can manually create and revoke that password, is my example from the Jenkins piece, but we can also set leases and use the number of uses on those secrets. So I can say, hey, go get me a username and password in AWS, and it expires in 5 minutes automatically, or 10 minutes, or a day, or whatever. So you can set a lease on that secret where it will automatically expire. So Vault will actually go to AWS in this example and remove that user from IAM, and it's no longer valid. So that's pretty powerful as well. And you can also set create a token or a use, especially around tokens, where you can say you can use this 3 times, and then it's no longer valid. So you can revoke leases based on lease period. So that's what I was just talking about there. Manage access to secrets using ACLs. So within Vault themselves, you can create paths. So you have paths. So you can say, under my secret, almost, if you will, like folder structure, you can create secrets, and then you can have, apps, and then under for each application underneath of apps, you can have access to your different applications in there. So app 1, app 2, app 3, and then underneath of each one of those folders, you can have, all your username and passwords, your credentials that application needs. And so if you have a development team that focuses on application, XYZ, you only want to give them access to the credentials for application XYZ. They don't necessarily need access to credentials for application, ABC, whatever. So you can use policies and ACLs to restrict and permit what those users, in this case we're talking about human users, but what those users can actually see and do within Vault itself. So Vault has a detailed audit log, right, for all interactions within Vault. So those can be sent to a syslog server, they can be written to a local file, etc. And we'll kind of go through that more in detail. Vault has a option or a feature called Transit. It's one of the secret backends, but it basically provides encryption as a service. So you can send plain text or data to Vault. Vault will encrypt it and return the encrypted data back to whatever application it is, and then they can actually store that encrypted data, wherever. So they can put it in S3, they can put it in a database, etc. So that way, the data being stored is always encrypted. Vault handles all that from the decryption and encryption piece. So you can use Vault for that. Vault this is another secrets engine, PKI. So you can have Vault act as, it could be a root CA or it can be like a secondary. So you can actually have Vault be part of your certificate authority chain here, and then it can actually dynamically generate X509 certificates for your internal infrastructure. So the benefit there is you can obviously automate that and programmatically, get certificates. Where if you're, technical in nature and you've done some of the certificates in the past, that, it's a pain in the butt to get some certificates. Sometimes it's a manual process to generate a CSR, go to the CA, you request a certificate, get the certificate back, upload that back to the system that you're trying to get a certificate for. Well, by using PKI secrets engine, you can do that programmatically and very quickly. So it has built-in high availability, Vault does. So we'll go through these in detail. So Vault, from an open source perspective, has built-in high availability, but then once you move to the enterprise version, we get additional capabilities as well. And then it also has interactions using, an API, a CLI, so you can just kind of log in and do things, or it also has a UI as well that, maybe humans are going to go in and modify or add secrets or manage it like that. That's kind of a brief introduction to Vault itself. So where Vault fits in the HashiCorp offerings, right? So they've got Run, Nomad, they got Secure. That's obviously Vault, so manage secrets and protect sensitive data. Provision, Terraform, and then Connect, Service Mesh, right? Made easy. So it does Connect does a lot of, Consul does a lot of stuff as well. From in a head perspective, these are kind of things that I presented this at kickoff, but these are kind of some of the things that we think Vault will be is ready for an enterprise right now. So Vault right now is enterprise ready. We know the cloud must be enterprise ready to allow teams to innovate. So Vault and solutions must be security and compliance standards along with the any deployments that enterprises are doing, right? So tools have to be API first. So Vault is definitely an API first tool. There's actually a lot of things that you can do. You can do everything with the API. There are some things you cannot do in the UI or CLI, so it requires the API. Organizations are looking to overhaul security as they move into the public cloud. So as I mentioned before, removing static long-lived secrets, right? So moving to those dynamic secrets, and automation of PKI, what we just talked about. Driving adoption, for Vault is something we can help as well. So integrating with development teams to start consuming Vault as a service there. And then, in the past, we've provided code and documentation, to dev teams so they can start, onboarding with Vault, and they don't have to do all of the research themselves, and they understand, how to write their applications to take advantage of Vault. And obviously DevOps enablement, right? So integrating Vault with existing or new deployment processes, and then trying to reduce or eliminate manual steps associated with getting access across the organization there. So stop real quick. Anybody have any questions that they want to ask as we kind of get into the components and how Vault works? You can also drop it in chat as well. I can watch that. All right, cool. So let's talk about protecting data. So how does Vault actually protect your data? So we'll start off with encryption key. So when you initialize or create a Vault server, it will create an encryption key. That encryption key is actually used to store and encrypt your data on the Vault backend. So Vault has multiple backends that you can use, and we'll discuss that as well. In order to protect the encryption key, we create a master key, right? So that master key will encrypt the encryption key and protect it. What we don't want is to have to give out the master key to one individual, right? Because then as kind of a security risk. So what we can do is use Shamir's secret sharing algorithm, and we can actually break that master key up into multiple keys. So the default is 5 keys with a minimum of 3 keys to actually unseal Vault. So by default, Vault comes sealed, where you can't access or write anything. In Vault, you have to unseal it using all the different key shares. So that's one way we can work with Vault and protect the data there. So what we do is those key shares, generally, we're going to give those out to 5 different people, right? So we're going to hand those out. So each, so those 5 different people don't have access to more than 1 key. And ideally, when we actually tell Vault, say, hey, we want to initialize it and create those keys, each one of those 5 people can give me their actual PGP key, and then I can encrypt that key, so the actual key share, with their PGP key. So even myself as a Vault admin, I can't even see what the keys are. So we can protect the data that way. And then what happens is we want to unseal Vault. As I mentioned, it comes in a sealed state. So we take 3 of those folks. We say, hey, we need your 3 keys, because as I mentioned before, the default is 5 keys, and you can tell it to break it apart however many keys you want. So I can say I want 10 keys, I want 20 keys, etc. And then you tell the threshold of the number of keys that you need in order to unseal Vault. So in this case, we did 5 keys, and with a threshold of 3 keys to unseal Vault. So what we're going to do is get 3 of those folks that have keys to provide us with the key. So underneath the Vault there, you can see I did this is an example of if you log into the CLI and do a Vault status, you can actually see that the seal type is the Shamir. So we talked about the Shamir sharing algorithm, where it breaks apart the keys. You can see that the Vault in this case is actually sealed. So we can't do anything with Vault except for really unseal it. You see the total number of shares on here is 5, as I mentioned before, the threshold of 3. And the unseal progress, we've given it 0 of 3 keys to unseal it. So the first thing we'll do is we'll have 1 key submitted. Now we have, the unseal progress is 1 out of 3. Well, this guy has a key 2 out of 3, and this guy 3 out of 3. So now you can see that seal type is still Shamir, but now sealed is false, right? So it's actually not sealed any longer, and Vault's kind of open for business. So we can kind of use Vault to do whatever, start configuring it, etc. So that's one way. That was the more traditional way of unsealing Vault. That was the only way you could unseal Vault if you were running open source versions. If you had an enterprise version before version 1.0, you could use Cloud Auto Unseal. Thankfully, HashiCorp moved Cloud Auto Unseal into the open source version. So now anybody running open source can actually use Cloud Auto Unseal to unseal Vault. So what is Cloud Auto Unseal? It basically delegates the unseal responsibility to some type of trusted device or service. So in our case, I know most of you folks know I'm an AWS guy. So instead of using the Shamir's sharing algorithm, we can delegate that responsibility to something like AWS KMS or Azure Key Vault or something like that to allow it to decrypt the master key and allow us to read the data and unseal Vault there. So the master key is encrypted with the service, so my example KMS, and they can decrypt at startup and unseal automatically. So if you go back to our example here with the 3 folks, if you restarted Vault or something happened with Vault from a disaster recovery standpoint, when you restart Vault or that instance or server comes back up, it comes back up in a sealed state. So if that were to happen at 2 a.m., well, guess what? If you're using the Shamir's sharing algorithm, 2 a.m., you have to call at least 3 of those folks to provide their key to unseal it. So it wasn't necessarily great from an enterprise standpoint where you got multiple people have to get up, VPN in, provide their key, etc. So in this case, once you restart, using Cloud Auto Unseal, once you restart Vault, the master key is automatically decrypted using that service, and Vault comes up in basically an unsealed state. So now you can use it again. So from a Cloud Auto Unseal support, it supports AWS KMS, Azure Key Vault, GCP Cloud KMS, or actually a physical HSM, if you're using it. So if you have Vault deployed on-prem or something like that, you can use a device like that. Again, as I mentioned, it was previously an enterprise feature, was moved to open source in version 1.0, so it was actually announced at HashiCorp in October, I think it was. and 1.0 came out in, I think, somewhere around like December maybe. So you can actually migrate from the Shamir sharing algorithm to Auto Unseal and vice versa. So you can, I don't know why you want to go backwards, but so if you have an existing Vault cluster and it was using a Shamir sharing algorithm before, you can migrate to Auto Unseal and take advantage of that now. So that was how we protect our data. The next piece, we're going to talk about the key components of Vault itself. So the key components that we're going to discuss here, we're going to talk about the storage backends. So where does the Vault cluster actually store your data? So store the passwords, any encrypted data, anything you store in Vault. Talk about different authentication methods. And this means how do I authenticate to Vault itself so I can get access to the data held within. Talk about secrets engines. So secrets engines are the reason we deploy Vault, right? We want to do, key value storage to store those long-lived secrets that may not change. We want to deploy an AWS secret engine to dynamically create those AWS secrets for us. So that's the critical piece of Vault itself. That's like, the guts of Vault, if you will. And then we'll talk about Audit Devices as well. So those are kind of the four key components, if you will. So jump into authentication methods. So authentication methods are exactly what they sound like. They're components that perform authentication to Vault itself. So, we have a Vault server running somewhere. How does Vault know that I, as Bryan Krausen, have permission to go read certain, secrets within Vault? So the authentication methods, there's multiple authentication methods that we can use, and those are responsible for assigning identity and policies to the user. So you can have multiple authentication methods enabled, and those are all depending on your use case. So if you are a GitHub user, you're in AWS, if you're in Azure, whatever, you can enable certain authentication methods basically based upon your use case and how you want to write your application to take advantage of Vault itself. Also, the default authentication method for new installs is actually tokens. So when you initialize a Vault server, so we talked about before, we get the 5 keys, the 3 keys, etc. But you also get the root token, and that provides your default access to Vault itself. And the idea is that we would enable an authentication method, write policies to give certain users, full admin to the Vault cluster, and then we would eventually revoke that root token so nobody actually has access to it. So authentication methods, we talked about, how do they know who I am? So from an authentication perspective, but what about an authorization piece? So within Vault, we can write policies, sometimes referred to as ACLs, and they basically dictate what an authenticated user can do within Vault. So, hey, I'm Bryan Krausen, cool, you know who I am, I've authenticated. What can I actually do once I get into Vault? Can I read these secrets? Can I go, enable new secrets backends, can I enable authentication methods, et cetera, if I'm an admin? So those are what ACLs actually do for us within Vault. So they can be written in HCL or JSON, and policies are denied by default. So if you don't give them, explicit access to do something, they don't have access to it. So the simplest form, includes a path. So something like my example here, secret, / application. So a secret would be like a KV store maybe, and then you'd have a folder, if you will, below called application. Do I have access to that folder, and I can see all the secrets held within that. And the capabilities are that we can assign our users, create, read, update, delete lists. There's also sudo in there as well. That some of the capabilities require. So again, I can assign a user, give them access to only read a certain secret in there if that application only needs access to that one individual secret, and then obviously restrict them from everything else because they don't need anything else. You can actually have more complicated policies, than just that. They can include things like variable replacements and parameters as well. So a couple of simple examples here. So I have a path of secret / app. So that could be your KV store, as I mentioned, so just simple key value store. And I can give that user just the capability to read passwords underneath the app folder there. More detailed policy may have, secret metadata, and, entity ID would be the person logging in. So you could use this policy to say, hey, I'm Bryan Krausen, I'm logging into Vault. It would replace identity ID there with my username. And so you can actually kind of use this to, if you want to set up individual, paths for users, they can kind of have their own vault, to store maybe personal stuff or, their own stuff that may not be shared in there. So in this example, I have capabilities of list, but the parameters as part of the secret, have to be a certain, a certain thing. So they can create a secret called foo, and the value can be bar, but the values have to be either zip or zap, right? So you can get pretty detailed in regards to what users can do, within Vault. So authentication methods, as I mentioned, there are a lot of different methods, authentication methods that you can enable. App role, I won't go through all of these, but app role is example used. HashiCorp recommends that for machine-to-machine authentication. So if you have an application that needs access to Vault secrets, then you would generally use app role. But you can do things like AWS. AWS actually uses, it's not AWS credentials like IAM users or anything like that. It actually allows instances within AWS to authenticate against AWS, provide that to Vault. Vault turns around and says, hey, AWS, is this legit? And he's like, yep, you're good. Then he gets authentication through that. So there's not necessarily a username and password or a token passed, if you will. Then you have GitHub, right? You can integrate with GitHub. So if I have a GitHub, username and password, I can enable that and actually authenticate into Vault there. Obviously, the most common is going to be something like LDAP, or Okta. You can have tokenization. Again, that's the default. And you can actually enable local username and password on Vault itself. So it would manage usernames and passwords there. So just an example of some of the authentication methods that are supported. So going into storage backends. So storage backends are exactly what they sound like. They configure the location for the storage of the Vault data. The storage backend is defined in the main Vault configuration file. So when you stand Vault up, you say, hey, these are my parameters for my Vault cluster. This is where I want to store all my data. So that's held within a configuration file itself. One thing to note that not all storage backends are created equal, right? Only some of them support high availability. Others have, better tools for management protection. So, if you decide to use a backend of file, right? Obviously, you don't have many options around file. You don't have services and things like that, like you would have for, say RDS or DynamoDB or, Consul. Like they have better tools for management and protecting that data than just storing it in a local file where you could just, you'd have to rely on the third-party service to back that up, in case Vault goes down. So I will mention that the only HashiCorp supported backend right now for enterprise is HashiCorp Consul Enterprise. Everything else officially is community supported. So if you were deploying Vault Enterprise Premium or Pro, you have to run Consul Enterprise on the back end for storage. Now, what that gets you is, when you buy Vault, they actually give you those Consul licenses. So it's not like you have to go buy Vault and then also go buy Consul. So with with Vault Professional, Pro, or Enterprise, they give you enterprise licenses for Consul to run at the back end. But just know that Consul is the only backend supported. I think File maybe as well, but Files, it doesn't provide much there. So an example of the configuration file here. So the one on the left, DynamoDB. So this is what I started off using and sometimes still use for a demo. Just quick and easy. So you say storage, backend is going to be DynamoDB. You have different parameters for that, right? Region is going to be UST1. The table within DynamoDB is called Vault Storage Backend. So that's how you would set up, DynamoDB. I've got TLS disabled on there, so you definitely want to use that in prod, but just notate that. For a Consul client, so you would use, as I mentioned, Consul is the only supported backend for Vault. HashiCorp does not recommend that Vault talks directly to Consul. What you would have is the Vault nodes themselves would run Consul in in the client, as a client, and Vault points to its local address right here, 127.0.0.1 over port 8500. The Consul client itself talks to Consul because it's part of the cluster running as a client, as a member of that cluster. That's how each node would be configured when you're using Consul. So for storage backends that we support for Vault, so there's a lot of storage backends. At Azure, we've got Consul, DynamoDB, etc., file system, Google Cloud Spanner storage. In memory, you can actually just store it locally in memory. Obviously, it's not going to persist if you restart, so you can run Vault in if you start Vault up in like a dev mode, it'll actually use in-memory storage backend. So, and you restart that server, like it wipes everything. It's not persistent. The ones with stars here are the backends that support high availability. So just to give you a heads up there. So that's storage backend. So let's talk about secrets engines. So secrets engines can store data, so like KV. They can generate data or secrets, like my example of AWS or PKI, or they can encrypt data. We talked about the transit capabilities earlier. So you can have as many secrets engines enabled and used as you need it, based upon your use cases there. Secrets engines are enabled and isolated as a path. So we saw before we had /secret/ like application. /secrets would be like the path that you enable a KV store on or something like that. I think secret or secrets, I forget, is the default path for KV. You can call it whatever you want. And then all interactions are done directly with the path itself. So if you're reading, if you enable a KV store, you would read /secret/ whatever. You wouldn't necessarily, KV is not necessarily part of the path. Same thing with AWS. You can enable an AWS secret engine, and then you would interact with it by reading, /AWS or /Amazon, whatever you want to call it. That's how you'd read and generate credentials. It doesn't necessarily have to say anything with AWS in there. The only thing is paths must be unique within the deployment. So you can kind of see an example there. Secret applications, app1, secret service accounts, SQL. So those are kind of two examples of paths that are unique and could exist within Vault. So again, you can have multiple paths of secret or multiple paths of secret applications, etc. Oh, there's two examples real quick. So on the left there in the red, I forgot I had that on there. That's just the command line to enable secrets. So if you want to enable secrets, say AWS, Vault secrets enable AWS, pretty easy. All interactions are done with the path. So as I mentioned before, Vault read and be like /AWS creds and then the role. That's how you would generate credentials for AWS. So continuing on secrets engines, paths can be replicated using performance replication. That's an enterprise feature that we'll discuss later today. Paths can also be local only, so in other words, not replicated, right? So in order to do that, we use mount filters. So the example here is we have two Vault clusters. They are using performance replication. So say we have one, in Charlotte on the left and one in London on the right. Say for example, because of GDPR, we didn't want to replicate the data in London, back to the US to make sure we satisfy GDPR requirements. So we can do is okay, production's cool, we're going to replicate that both ways. Infrastructure's cool because we may need some of those secrets on both sides for our applications, but we don't want to replicate Charlotte and London because those are actually secrets that are applicable to only Charlotte and only London. Or again, GDPR, we don't want to replicate things from Europe back into the United States. So we can use a mount filter and basically, say, hey, these are going to be local only to this cluster. They're not going to be replicated to the other cluster. So from a secrets engines perspective, we have a bunch of different options here. Active Directory. So for example, we can actually go and create dynamic AD credentials for applications that need them. Assign policies to them, permissions, whatever. AWS, as I mentioned, go out and create, a IAM user. It would go out and create an access key and a secret key, and also apply an IAM policy to it. So you can say, when you create a specific role in there, you can say, I only want this role to be able to read EC2 or stop and start EC2 instances that have a tag of dev, right? So only development servers I can stop and start. So we can do that across the board. It supports a lot of different things, a ton of databases. Key value store is kind of one of the default ones. I think that stuff is default when you go in there. PKI, as I mentioned, the certificates, transit on the bottom right. That's our encryption as a service, if you will. Time-based one-time password is actually pretty cool. Kevin Tuffner has a great demo on that where you can set up Linux boxes to authenticate against Vault. So you go to Vault, request a one-time password, and that's what you use to authenticate to a Linux box to SSH into it, and it's only used one time, right? So once you log out, then you have to go back to Vault, authenticate, and get another password in order to interact with those Linux boxes. Databases that they support, I think there's a new one on here that's not listed, I forget what it is, but they do support a lot of different databases. So, SQL, MongoDB, PostgreSQL, MySQL. Shanks is a great post around doing dynamic creds on, I believe, Postgres, maybe MySQL, I forget. So you check that out as an example there. But, the idea is that the application, the web front end or the application tier, obviously needs access to talk to the database on the back end, but may not need that 24/7, right? So right before the application needs access to the database, we go to the database, generate dynamic credentials, pass it back to the application, and the application can use those creds to interact with the database. Once it's done, then we kill those credentials. So again, trying to move to dynamic versus long-lived secrets. So last piece around the component here, Audit Devices, again, does exactly what it sounds like. Keeps a detailed log of requests and all of its responses, within Vault. So the audit logs formatted by JSON, sensitive information, say like the usernames and stuff like that, or the credentials that it creates, they're actually hashed before it logs, so you can't actually, just go through the log and gain access to something. So the final one is, you can and should have more than one audit device enabled. See below. Vault requires that at least one audit device be available to write the log to before it actually completes the Vault request. And I have if enabled. So you can run Vault without an audit device, and it works perfectly fine. I don't know why you'd want to do that, especially from an enterprise standpoint, but you can do that if you want. However, if you enable an audit device, say for example, you're sending your logs to a syslog server, Vault requires that it is able to write that log before it'll actually respond back to the request of the client requesting, a token or whatever, or reading a secret. If, for example, that syslog server goes down, or somebody changes a firewall in between there where it blocks communication between Vault and that syslog server, and that is the only audit device you have configured, Vault will stop responding to all future client requests until it is able to write to the audit device. So that goes back to the comment above it. You can and should have more than one audit device enabled. So that way, if something does happen, somebody writes a firewall rule and blocks it, you can have a second log, say a local file or something like that, where it can still write and it doesn't take Vault down. So just kind of note that. So Vault has three different types of audit devices. Files, you can write to a local file. You can use something like FluentD or just a similar tool to like send those logs somewhere else. Obviously, you have to watch the storage, from an instance perspective, VM perspective, whatever, to make sure you're not filling up the hard drive there. You can write to a syslog, my example before. It always sends to a local agent, so it's kind of a pain in the butt. So you may have to install a local agent and then have that agent, send it off somewhere, or stock it. You can write to TCP, UDP. It's unreliable, right? Because obviously the underlying protocol, we don't want to rely on UDP, to send our logs that we desperately care about, because obviously UDP doesn't care if it gets there or not, it just sends it out. So you shouldn't use socket when strong guarantees are required. So we have to have every single audit log, every single log for interactions within Vault. You don't want to use socket there, so we want to use one of the other two. All right, so we'll go into Vault High Availability now. So this is probably slide's probably in the wrong place, but this is kind of what an enterprise Vault deployment may look like. So we have a minimum of 3 nodes, and that's because of leader elections and the protocols that we use for leader elections. We want to make sure we have a consensus of who can we can elect a new leader if by chance the active node goes down for some reason. As I mentioned, the Consul agent runs on the Vault nodes themselves, but it runs in client mode, not server mode. And so that agent is what allows it to become a member of the Consul cluster and interact with the Consul servers at the bottom. So by default, we're going to have like our quick start for Vault itself. We'll have 3 nodes of Vault, and it will have 5 nodes of Consul. So Consul will store and replicate the data across those 5 nodes on the network there. So, and we have the load balancer there. So let's talk about local redundancy. You can stand Vault up in a single node if you want to. Obviously it's helpful when you're playing around with Vault, learning Vault, etc. But the easiest way to get local redundancy is to spin up additional Vault servers, form a cluster, and now you have a primary node and multiple standby nodes. So those standby nodes you cannot read or write from those local standby nodes. Only the primary node will do that. So when you have when you're accessing Vault, as I mentioned, ideally you would go to the primary node. So you can put a load balancer in front of Vault if you want to. I think that's generally a recommended practice. Or you can use something like Consul, to figure out what the primary node is if you're using Consul from like a service mesh perspective. If by chance you're behind a load balancer and you get sent to a standby node, that standby node is aware who is the primary node and will actually route that traffic to the primary node, get a response, and send it back to the user. So you're not, there's no necessarily problems with hitting a standby node. It's just necessarily not ideal. So from a load balancing standpoint, you can do, this was an AWS slide, so it has ALB, but it can be Azure or wherever. It could be on-prem, F5, whatever. But you can front-end Vault, with a load balancer. The load balancer itself is used for high availability in this case, not load balancing. As I mentioned in the previous slide, only the active node will respond to reads and writes. So we're not necessarily load balancing across the 3 nodes. We're just ensuring that we're using the load balancer for things like health checks and routing the traffic to only the healthy node, or I'm sorry, the active node, I should say. Vault itself has an endpoint that you can health check, so v1 sys health, and then status code. So when you hit that endpoint, you will get an HTTP status code. So if you get a code of 200, it means that you've hit a Vault server that is initialized, it's unsealed, and is actually the active node. So that's the one you want, right? We want to be sure that we're hitting the Vault node that's responding with a 200. Any other HTTP code is basically not the Vault server that we want to hit. So like a 429 means he's unsealed, but he's a standby node. So he's going to, again, forward that traffic to the active node there. Sorry, I can get a drink. All right. So the example down on the left, you have the AOB. He's going to talk to Vault over 8200, which is actually the default port of Vault. So he's going to health check that v1 sys health. He's going to respond to 200, so that means that he's the active node. You see the other 2 standby nodes down there are responding with a 429, so we're not going to send traffic to those from an AOB perspective. All right, so we'll talk about additional high availability when we get into the enterprise side as well, but those are the kind of the pieces that are built into open source. Let's talk about disaster recovery for Vault. So the most critical task protecting Vault is protecting the back-end storage, right? So in my example before, it was Consul. So how do we back up our Consul servers using snapshots and stuff like that to ensure that we can restore that data? So you want to use the storage backend's built-in features to help manage the backups or snapshots. And then you want to, traditionally, as we would with any other backups, we want to store them in multiple places to ensure that, we have access to our data. So if you're using DynamoDB, something like that, you can take DynamoDB snapshots. If you're using Consul, you can use Consul snapshots and store the state, and then you could restore that state, Consul, and then you can restore Vault to read that data. So Consul snapshots, again, I focus on this only because it's, as I mentioned, it's the only supported backend besides file for enterprise. So Consul snapshots will save the state of Consul servers, for disaster recovery. So it'll save things like the key value, so all those long-lived passwords you talked about, service catalog, any prepared query sessions and ACLs as part of the snapshot itself. So you can, set up the Consul agent. It can snapshot Consul, every hour, every day, whatever you want. Just depends on how heavy use your Vault clusters are. You can also run a one-time snapshot or use the Consul agent, right, for automatic backups. That is an enterprise feature, but so the one-time snapshot will be helpful in something like a pipeline. So you want to upgrade Vault, you want to use maybe I don't know, immutable infrastructure or something like that. So you want to just replace your Vault servers. You can actually go to before you do anything, you actually go to Consul and take a snapshot. That way you can restore, similar to how we used to do in like the VM world before we did Windows updates or major updates to a VM. We go take a snapshot, go do the thing. If it works, great, we'll delete the snapshot. If not, we can revert to that snapshot and be back to the state that we were before. So the example here is Consul. You can take multiple snapshots. Again, every hour, every day, whatever you need to. From an AWS perspective, you can actually configure to just drop those snapshots on S3, and then so now you have snapshots in the local Consul cluster. You have them on S3. Then you can also use S3 to move those to like a secondary region. So now you have those off-site, outside of your region. So now you have multiple places that your data is stored. So Autopilot, as part of Consul itself, is a built-in solution to manage like the Consul nodes. I'll try to go through these quickly because again, I want to focus on Vault, but Consul stuff is important because it is, the critical back end of Vault. Consul goes down, Vault goes down. So Consul is just as important, for running Vault. So Autopilot is basically a built-in solution to help with managing, your Consul nodes that support the Vault backend. It has, options for things like dead server cleanup. So if one of the Consul nodes dies and then it detects that another one was stood up to replace it, it'll immediately reap that dead server and take it out of the cluster for you. Where before it would take, I think, like 3 days or something like that in order to do that. Now we can reap those dead servers quickly, get them out of the cluster, and we can kind of, move on with life, if you will. We've got servers, make sure that that they're stable, right, when they come up. So we don't want to introduce a Consul server or Consul node to the cluster unless they've been stable for 5 minutes or 30 seconds or whatever. We don't want to put something brand new in there that could cause problems. So Autopilot can make sure that he's participating in the cluster, but he's not necessarily a voting member until he's been stable for X number of seconds or whatever you determine. Redundancy zone tags. So this is a way that when we deploy Consul, we can kind of set up fault zones to ensure that we have voting members in different fault zones. So in a public cloud, we generally have in like AWS, we have a region and we have availability zones. So we, each one of those availability zones is a fault zone, if you will. So we can set up tags to say, hey, you're in fault zone 1, you're in 2, you're in 3, and that way when we do updates or we do failure or something fails or whatever, we ensure that we have voting members across those different fault zones, and we don't run into the problem where we have, the 3 voting members, are in one fault zone, and then that zone goes down, and then we have the other members who are not voting members are kind of sitting there and they can't necessarily vote for a new leader. So that causes problems there. So we want to make sure that we have voting members across all those different fault zones, so we can, our Vault cluster will continue to live on if we run into the chance that one of those fault zones goes down. We also have upgrade migration too. I've got an example in here. So if we were running console, like 1.3.0, we're going to 1.4.0. It'll help ensure that the newer version doesn't get voting rights until there's an equal number of newer servers versus older servers. And I'll give I've got an example on that in a minute. So Autopilot just knows on by default you want to disable features that you don't necessarily need. You can also configure those each individual feature as you see fit there. So I'll go through these fast. I've talked about most of them. Again, remove did server cleanup, remove failed servers from the node or from the cluster itself. Servers, all right, let's see. Oh, sorry. The configurable time is default 5 seconds. So the server has to be stable for 5 seconds in order to become a full voting member. You can change that if you want as well. Redundancy zones, example here. So we have 2 AZs. Again, sorry for the AWS stuff. But so we have 2 AZs here, right? Each one of those is officially a fault zone. We have the 2 voting members at the top. So we ensure that we have a voting member in each fault zone there. If we want to upgrade the guy in the top right there, what happens is we can move. It'll ensure that the voting member actually stays in availability zone 2 and it doesn't move to the other one in AZ1. We can upgrade that guy, and then so we ensure that we have voting members across those fault zones. Upgrade migrations. Again, the example, we're moving to a newer version. So in this example, at the bottom, we have 2 servers running 1.3.0. They are voting members. We add a 1.4.0. He is not a voting member yet. We add another 1.4.0 server. They become voting members, and we actually remove voting rights from the old servers now, and then we can easily remove those old servers, from the cluster and start running on 1.4.0. All that's completely automatic, happens in the background. And here's some quick screenshots of me doing that. So you see at the top and bottom, we have the old nodes running 1.3.0. You see the bottom arrow, they are voters. I added a new node running 1.4.0. He is not a voter. So now in this case, I added another 1.4.0. You can see at the top and bottom again, the old nodes are now demoted, so they no longer have voting rights. The new node 1.4.0, there's actually another one you can't see in the screenshot, but now the 1.4.0 servers are actually voters, so they have voting privileges, and the old ones do not. Oh, sorry, the two new ones are on the bottom. There's an old node that's off the top of the screen there. So that's console. Again, I always think it's important because, again, as I mentioned, if console goes down, Vault goes down. So let's talk about the enterprise features. Moving out of open source. So replication is an enterprise feature. Basically allows Vault data to be copied to a secondary cluster for both disaster recovery purposes and performance reasons. So replication is basically how you extend Vault to another data center or another region or another, if you're on-prem and you want to go to cloud, so you can extend it out there as well. And I have more details on each one of those. Basically, replication, it requires a manual failover to the other cluster. So if your primary cluster goes down, your secondary cluster doesn't come up automatically and start responding to queries, because what happens if you just have a network blip, right? Like Vault wants, HashiCorp wants the customer to determine what is a failure, right? If we just have somebody puts a firewall rule in, in 5 minutes we figure it out, and then we fix it, right? Is that a failover to the business, or is that can we last longer than 5 minutes without faults? You can automate this, using something like Jenkins, but the job should be manually kicked off, when you determine that there's actually a failure. So there's 2 options for replication here. So DR and performance replication. We'll touch on those here. So DR replication basically is a warm standby if the primary fails. So it mirrors everything in Vault. So it mirrors secrets, policies, and it also mirrors the authentication tokens and leases. So if I'm going, again, getting tokens or a dynamic AWS cred or something like that from the primary cluster, that will actually be replicated to the second cluster. Just know that a disaster recovery server or cluster, so the one on the right in this example here, it does not service any client requests at all. So you can't read from it, you can't write to it. It's only like a warm standby. So the example here, read, write, the primary cluster will service that, the secondary will not. So you want to go to the primary. Again, talking about enterprise features, disaster recovery requires at least enterprise professional license. You don't have to go up to premium to get that. Sorry, I'm talking a lot. So disaster recovery, replication, a couple things that we want to notate here. Obviously it requires connectivity. Again, this is, sorry, for AWS stuff, but these are notes from an AWS presentation. But connectivity has to be established between, your on-prem data center and your cloud provider, or multiple regions within your cloud provider. Example, you have to have network connectivity between those in order for those to communicate. In AWS, likely accomplished using something like VCP peering, a transit network, so using something like Cisco CSRs or Palos or Checkpoint or something like that, or use the newer transit gateway. The DR nodes should be architected in a similar fashion as production. So we want to make sure that we're using things like multiple availability zones for our DR cluster. We want to make sure we're using maybe spread placement groups if you have multiple nodes within the same AZ. So from a VMware perspective, those would be like anti-affinity rules to ensure that no two nodes are running on the same underlying physical hardware. That way, if that hardware goes down, we hopefully should only affect one node and not multiple nodes within the cluster. Security groups, firewalls, et cetera, should permit communication between the primary and secondary cluster. Don't forget to permit the clients. So just because you have clients being permitted to the primary cluster, if you do fail over to the secondary cluster, right, all those same clients will need access to talk to the disaster recovery cluster as well. And then you can use things like a DNS health check to fail the primary Vault DNS record to the DR cluster. So if you have a load balancer internally, if you're using public cloud service like Route 53 or something, you can actually have health checks to say, hey, if this guy's completely down, then we're going to manually fail over, but now we want to just change this DNS record to point to the DR cluster instead. So that way we don't have to go and re-architect our applications or anything like that. They can all point to the same DNS record there. Or you can use Consul from a service discovery standpoint. So performance replication. Performance replication is the way to extend Vault to other regions, other public clouds, other data centers. If you have multiple data centers, right, and you want to extend Vault to those data centers, you would use performance replication. Performance replication mirrors all the secrets and policies. So anything you set up, so long list secrets, any of the ACLs, but it will not replicate the local tokens and leases. And that is because the local servers, the local clusters, will actually service local clients for tokens and leases. So the last part is it will service local clients' requests for static secrets. It will also go out and create dynamic secrets and leases separately from the primary cluster. So our example here, primary cluster will both service both reads and writes. Our secondary cluster will actually service reads, but any writes will go all the way back to the primary cluster there. So our example, you've got somebody who wants to request a token, from the primary cluster in region 1, for example. They will go to their cluster, and same thing in region 2. You got a request on region 2. They will go to their local cluster, and that local cluster will actually return a token. And when I say token, it can be a token, it can be dynamic credentials for a database or AWS or Azure or whatever. The local server will service the local clients. Performance replication requires enterprise premium, so the highest license of Vault. So a couple of things about performance replication. You want to place performance replicated clusters near the applications that it will service. So think the same region, same data center, et cetera, even down to in AWS, same VPC, same AZs, et cetera, to minimize traffic. You want to use a separate DNS record for communication to the local cluster. So if you have a primary cluster, you may have, our example for Charlotte, vault, and our one in London, we have London vault dot, ahead.com or whatever. So then your local clients have a DNS record to communicate with their local vault. Should be used heavily for applications needing, read-only access. So if you have applications somewhere else, you can actually point them to the, the performance replicated cluster and have them, do all the reads from Vault there. As we talked about before, use mount filters to limit what secrets are replicated. They can be used to satisfy, GDPR requirements. So continue on with enterprise features here. So namespaces. Namespaces provide basically a vault within a vault, right? So it allows the infrastructure team to deploy Vault and then start providing, more Vault as a service to the organization. Namespaces will generally be provisioned, and overseen by the infrastructure, but what it allows us to do is delegate, our namespaces or mini vaults, if you will, to different business units or teams. So if you have different development teams, et cetera, that may have different needs, you can create a namespace, give that to them, and they can you delegate the permissions for them to manage their own namespace or vaults within a vault, if you will. So example down here, I have a vault cluster, right? Then I can start creating namespaces in there, and each namespace is like its own vault cluster. So each namespace can have its own authentication methods, its own policies written. It can enable, its own secret backends depending on what's needed, and each one, will have a unique configuration based upon the needs of that namespace user. So whether that's a business unit, whether that's a different development team, etc. Each one of those namespaces can look completely unique. And just note that just because we have a namespace doesn't mean we can't use the root vault to do everything else as well. So still within root, we can have authentication methods, policies, etc. So again, this allows us to provide Vault as a service, if you will, to the business. We still own Vault, and we can still, oversee the Vault solution as a whole, but this allows us to delegate Vault to some other people. So we can give them permission to say, the development team leader, like, you own this namespace, so you can do, you can enable authentication methods, you can write your policies and secrets and all that kind of stuff as your team sees fit based upon your application. That's namespaces. Performance standbys, this is different than performance replication. So our example earlier when we were doing open source like HA, where we have an active node and we have multiple standby nodes, performance standbys basically give us the local nodes, but they are able to provide read-only services to Vault, as opposed to the regular standby nodes we talked about that are only standbys. They do not service reads or writes at all. They'll forward it to the primary node. So this way we can actually have read-only nodes. So again, read-only, all writes are still directed to the active node. You will need separate DNS records to point to those performance standby nodes. If you have applications that are read-heavy or something like that, they can point to those performance standbys and get read access to Vault. And so that's a way you can scale out reads with Vault. MFA, I'll just tell you what MFA is, but integration for identity validation. It integrates with Okta, Duo, Ping, time-based one-time password. So what it actually does is it uses the API for those solutions like Okta and stuff for push notifications. So if you log into Vault and you have MFA enabled, again, this is an enterprise, I think, premium feature. Basically, it'll use the application installed on your phone that's registered to that user, and it'll basically say, hey, are you logging in? You say yes, and it's like, okay, cool. That's how they do MFA on there to allow access or allow or deny access. to Vault there. Sentinel, so Sentinel is actually included with all 4 HashiCorp products for enforcement of policies and access control. I don't see a ton of use for Sentinel within Vault. Sentinel is generally more heavily used in things like Terraform, but you can use Sentinel in Vault. So basically what it does is it expands, your regular ACLs or policies to include both, RGPs and EGPs. So it gives you more options there. So an example may be, in order to read or the secret, this user must have authenticated with MFA, and then they also may have they need to come from this particular CIDR block, right, of IP addresses. Otherwise, they're not going to be able to read the secret. So just an example of what Sentinel can do. Awesome. So those are the enterprise features. Again, some of those are require Pro, some require Premium. Try to notate the ones that do. So licensing, as I mentioned before, licensing is changing. Before, licensing was per cluster. The problem was it wasn't necessarily cost effective for smaller customers. So if you have a customer that said, hey, we want to use Vault as a secrets manager to manage, long-term secrets. We're a small company. We have, 5 engineers that need access to it. HashiCorp was like, cool, that's $100K. Like, oh, okay, that's not necessarily cost effective for us, so we're just going to use a different solution. So the change in Vault licensing is hoping to address some of that as well. So the new licensing for Vault, I just reached out to HashiCorp, unsure when it's effective. Again, HashiCorp's in their SKO. I heard it's going to be effective after SKO this week, but I'll try to verify and let you guys know. All right, so Vault licensing. Vault is now going to be bundled into packages, and they're going to be t-shirt sized, if you will. So before it was per cluster. If you needed like a DR cluster, it was like half the price. If you needed a dev cluster, it was like half the price, etc. So what they're trying to do is create a package now. So each package of Vault consists of a production cluster, 1 DR cluster. Again, that's DR cluster and not performance replication clusters, so just note that. And then it gives you 2 development clusters to deploy and to be able to test with and stuff like that. So those are that's the package. T-shirt sizes. Vault. So you get small, medium, large, extra large. Small is, again, all these are going to be, 1 production cluster, 1 DR cluster, 2 dev clusters. But now what they're doing is introducing the number of API requests. So they're trying to size it like that. So if you get small, you get a small company that just needs it for, a few things. They don't want to, use all the features, etc. You can buy the small package. This is list price. I'm not sure if this was Pro or Premium, so I apologize. I'll try to find that out, but I just want to kind of give you a ballpark estimate there. So small, medium, you got 50,000 requests, 500,000 requests, large 2.5 and 10.5 million there requests, and those are API calls that use a token. And I've got the so I've got more information on that one. Just note that the small, medium packages, it's a maximum of 2 packages per customer. So HashiCorp's thinking behind that was, if you are buying, 3 small packages, then okay, you're probably using a lot. You're using Vault, quite a bit. You're getting much bigger. You can kind of afford, right, a different or additional, or moving over to a large package or extra large or whatever. So they don't want people just buying a ton of, small packages and, for cost savings there. So the 4 key components, and we talked about some of them before, of new licensing. So again, we got open source, obviously doesn't cost anything. You have professional or premium. So the idea what we want to do is, when we're talking to customers, is gather 3 to 5 requirements to help determine what version of Vault that we need. Do we need the features that are included in professional, or do we need to bump up to premium if they're looking for performance replication or MFA or anything like that. What that also helps us do is lock down a proof of value to help avoid scope creep. So if they say, hey, we want to do XYZ, I'm like, cool, we can help you, turn that up so you can, play around with it. You can kind of still help lock that down for your proof of value, so you don't have to worry about scope creep. Oh, Dan, yep, I've got that in this slide. So, so how many clusters? So again, the packages. If you need more than one production cluster, you have to buy more, more than one package. So clusters are going to be like, where do you want to run Vault? It's mostly likely going to be your data centers or, your cloud regions, etc. Very unlikely, you're going to run Vault in edge locations, smaller offices, etc. It's generally going to be your main data centers. The third piece is how many requests. So Dan, this is where I think we're going to answer your question here. So any call made to Vault to generate, use, or request a token is a API request. Actually, I got a typo in there, so I apologize. So like a KV request, requires a token, right, for authentication, so it counts. But a health check, to Vault does not count as one because we're just health checking it. It doesn't necessarily require a token. We're just hitting that endpoint that's available to anybody. So that's not a health check. So actually, a request is, defined as you're using the features of Vault, right? You're not just health checking or anything like that. So how do we determine the number of requests? HashiCorp does have a couple sizing tools. One's an Excel sheet, one's online. As far as I know, we don't have access to the one online. It's basically just like a couple slide bars, and it basically just does the math for you, but, we can easily do the math. So, how many, determine how many applications will use Vault, and how many instances of that application are there. So if we have an application, that's accessing Vault, 10 times an hour, but there's, 10 instances of that, right? You kind of do the math and figure out, the request there. What is the average number of calls per day? A lot of customers may not know that, so we may get down to hour, minute, to help us get a ballpark number, of the requests. So right now, HashiCorp has no way to determine how many requests are going to Vault. So they aren't necessarily enforcing the number of requests right now. So it's kind of, in a sense, based on the honor system or your agreement, with HashiCorp that, okay, we're going to stay under, 50,000 or whatever. There will be a future endpoint in Vault coming out, I think in the next version, that will allow both HashiCorp and the customer to check the number of requests going to the Vault cluster. So that will give you the ability to say, oh, we're way under the number of requests, or we could probably health check that, or send that to some kind of logging thing. Say, hey, we're trending upwards, and in 3 months we're expecting to hit over 50,000 requests. So we probably need to talk to a head or HashiCorp to get an additional license or a bigger license or whatever. So that'll allow us to do that. So then it won't necessarily shut Vault down, because right now there's no way to determine it. But obviously you're bound by kind of the legal portion of that, where you say, hey, we're only going to use it for what we bought the license for. The last piece is what support do you want. So they have both gold and silver support available. Gold support is only available for deals over 100,000. So just know that. And here's kind of the SLAs if you're interested in that. 60 minutes for first reply for gold, resolution within 24 hours. That's basically it.